So, uh, have you ever had that moment where you're using an AI coding tool and it feels like absolute magic?
Oh, yeah. Like you've suddenly got a superpower.
Exactly. You feed it a prompt, and suddenly it's effortlessly analyzing your architecture. It's spitting out these brilliant solutions, and you start to think, wow, my job is going to be incredibly easy from now on.
Right. You start planning your early retirement.
Right. But then maybe an hour later, that exact same AI is completely broken. You're pulling your hair out, and the magic is it's entirely gone.
It is a universally acknowledged truth in modern development.
Yeah.
The pendulum swings so quickly between feeling like a wizard and feeling like you've hired an intern who just refuses to stop making the exact same structural mistake over and over.
And that wild pendulum swing is exactly what we're exploring today. Welcome to this custom-tailored deep dive. We have a fascinating hands-on experiment to look at.
Yeah, this is a good one.
We're pulling from a piece documented in InfoWorld by senior writer Serdar Yegulev. Our mission for this deep dive is to unpack exactly what happens when you ask an AI, specifically Claude Sonnet, to migrate an entire application from Python to Rust.
It's the perfect test case, really, because it moves beyond the theoretical. We're not just talking about generating a quick script to sort a list.
Right, or writing a single standalone function.
Exactly. This is about translating a fully operational, multifaceted application across two very different programming ecosystems.
So let's set the scene for you. The author took a custom-built Python-based blogging system that he wrote himself.
A bespoke CMS.
Yeah, a robust server-side application.
Mhm.
It featured static HTML generation, per blog templates, category and tag management, and an interface that lets you edit posts using either rich text HTML or plain text Markdown.
And it even had a bit of JavaScript front-end code mixed in there.
Yeah, exactly. So he set out to port this entire architecture over to Rust. But before we get into the actual mechanics of how it went down, we should probably establish the underlying motivation here. Why choose Rust as the destination for this particular experiment?
The strategic reasoning behind that choice is it's a crucial part of the setup. Rust is famous for its strict correctness and safety guarantees.
Right.
Unlike some languages where you might, only find out your code is broken when you try to run it in production and then it crashes. Rust enforces these rules at compile time.
Which is notoriously strict.
Oh, incredibly strict. Think of the Rust compiler as a very strict editor who will not even let you publish the book until every single grammatical error, missing comma, and plot hole is fixed.
Okay, I like that analogy.
And the author reasoned that because Rust's compiler gives such immediate, rigorous feedback, an AI would actually benefit from that environment.
Like it would use the errors to guide itself.
Precisely. The hope was that the AI could use those strict compile time errors to automatically course correct, making the whole migration process much smoother.
Makes sense. Now, the tooling setup to test this theory was pretty straightforward. He used Google's anti-gravity IDE. For the AI agent, he started with Claude Sonnet 4.5.
Started with being the key phrase there.
Yeah, he actually had to forcefully upgrade to version 4.6 right in the middle of the project.
Because the older version was abruptly discontinued.
Right, which adds a fun little layer of unpredictability to the whole mix.
Yeah, changing engines mid-flight.
Totally. Now, I want to ask you, the listener, to think about your own workflow for a second. Have you ever tried to automate a tedious task, only to find yourself spending significantly more time fixing the automation than you would have spent just doing the work manually?
I think we've all been there.
Keep that feeling in mind as we go through this.
Because the setup phase is always the honeymoon period of any automation project. The initial promises look fantastic on paper.
Okay, let's unpack this. The very first directive the author gave the AI. He made a copy of his Python directory, opened up the anti-gravity IDE, and gave Claude a remarkably simple instruction.
What was the prompt?
He basically said, transition this project to a modern, high-performance Rust stack. He pointed the AI at the code base and just let it loose.
And this is where the magic happens. Claude analyzed the code and came back with a genuinely impressive, highly accurate architectural plan for the new Rust stack.
It really was. It didn't just stumble in the dark or pick random library.
No, it recommended Axum for the web layer.
Which is replacing Bottle from the Python app, right?
Exactly. Axum is a highly respected Rust framework for handling HTTP requests. Then it suggested SeaORM for the database interactions.
And for those who might not use RRMs heavily, you can think of that as a translator that lets Rust talk to your database smoothly without having to write raw SQL queries.
Right. Also pulled in Tera for handling all those per-blog HTML templates.
And then there's the big one. It recommended Tokio for asynchronous task handling.
That is a massive architectural shift.
Yeah, Tokio replaced the Python multiprocessing approach. That is not a one-to-one mapping at all.
Not even close. Python often creates separate memory-heavy processes to do multiple things at once because of its internal locks, the global interpreter lock.
But Rust, using Tokio, handles massive concurrency with lightweight tasks. The AI actually mapped the core concept of what the author was trying to do into the correct idiomatic tool for the new language.
If we connect this to the bigger picture, the reason Claude succeeded so brilliantly in this first phase is its approach to analysis.
How so?
Well, it didn't read the Python code line by line and attempt to blindly translate the syntax into Rust.
Right, it didn't just write Python with a Rust accent.
Exactly. It analyzed and re-implemented the program's underlying behaviors. It looked at the desired outcome of the application rather than just mimicking individual functions.
The author also noted that his Python app avoided using tricky features like dynamic imports.
Oh, that helps a lot.
Yeah, in Python you can load code on the fly while the program is already running.
Which creates this invisible dependency web that AI often struggles to map.
Right, so the lack of that feature definitely gave Claude a cleaner runway. But the real aha moment happened when the author looked at the initial plan and noticed a gap.
What was missing?
The AI hadn't created any placeholder data for the new database. No sample user, no sample blog post.
Which you need to actually test the thing.
Right, so he casually prompted Claude to add it. And Claude instantly updated the plan, generated the necessary data structures, and when the program restarted, the initialized database was perfectly populated.
That seamless interaction right there represents the golden dream of AI-assisted development.
It really does.
You describe the intent, you spot a minor omission, you ask for a correction, and the machine handles the heavy lifting instantly. It provides a tremendous sense of momentum.
Yeah, but here's where it gets really interesting, because that momentum hit a brick wall shortly after.
The honeymoon ends.
Abruptly. The next stage of the project involved discovering just how much Claude actually left out of its grand plan. Yes, the AI successfully built out the core page rendering logic for the blogs, but it built absolutely zero user-facing infrastructure.
Wait, zero?
Zero. No admin panel, no login page, no way to actually edit or manage the posts. It skipped the entire user interface.
Wow. This raises an important question, and it's a philosophical point the author grappled with.
Yeah.
In his initial directive, he didn't explicitly outline the need for an admin interface. He simply said, transition this project.
Right.
So who is at fault for the omission? Do we blame the AI for not thoroughly investigating the codebase to realize a CMS requires an interface? Or do we blame the developer for providing a vague prompt?
Well, I would argue that an AI trained on millions of web repositories should know that a blogging platform requires an admin interface to function.
That's a fair point.
I mean, it's not just a background script, it's a content management system.
Yeah.
It feels like a massive contextual blind spot to just ignore the front end entirely.
That is a fair critique of the model's contextual awareness. However, a large language model is ultimately optimizing for the literal text of your prompt.
Taking it a bit too literally.
Right. If you instruct it to transition this project, it might scan the most prominent backend routing files, establish the core data flow, and assume the UI components are either out of scope for this specific prompt or handled elsewhere.
It's not a mind reader.
Exactly, which is why explicit boundary setting is necessary.
Which forces you into what the author described as an exhausting loop. If you've used AI for coding, you know the cycle. Prompt, generate, test, reprompt, over and over.
The grind.
Yeah. You transition from an architect steering the project to a middle manager micromanaging a stubborn employee.
The author had to point out the missing UI, request a new plan to build it, and then painstakingly audit every single element of the admin interface to get it functional.
And the process turned into a cascading series of failures, a total comedy of errors. First, he tries to get the web templates working and immediately hits an uncaught runtime error.
Which is deeply ironic.
Very. The whole reason he chose Rust was to leverage its strict compile time checks to prevent errors. But the compiler could not catch a runtime error buried inside an HTML web template.
Yeah, the Rust compiler ensures the backend code is memory safe and structurally sound, but it has no visibility into the logic inside your front-end templates.
It's a black box to the compiler.
Right. It can't predict if a user clicking a button will trigger a broken template variable and crash the page. The safety net the author was relying on simply vanished at the system's edge.
So he manually gets past that template error, tries to load up the admin panel, and the login page is completely blank, just a white screen.
Beautiful.
Yeah. He goes back to the prompt generate test loop, gets Claude to generate the missing HTML, and the login page finally appears.
Progress.
So he types in his credentials, clicks login, and it takes him to a placeholder page that just reads, login logic not yet implemented.
Oh man, the AI confidently built the door, painted it beautifully, and neglected to put a room behind it.
Exactly. And even after he prompted it again to build the actual authentication logic, the code it generated for accepting and verifying the passwords was logically flawed.
It became a grueling grind through every individual component.
And this wasn't just a matter of minor syntax errors anymore. The AI began exhibiting core malfunctions.
Structural breakdowns.
Yeah. While the author was prompting Claude to implement the admin page for each blog, the system experienced a complete breakdown. It started spamming the console with the word core.
Just the word core.
That's core, repeating for hundreds of lines until it hit the token limit.
Which is the maximal amount of text memory the AI can process in a single window.
Right. It just hit that wall and crashed entirely.
Reaching the edge of the context window often causes these models to degrade, but a complete cyclical failure like that shatters the illusion of interacting with a highly intelligent assistant.
Totally. And even after it stopped the massive spamming, it started randomly appending the word core to the end of its regular, seemingly normal responses.
The memory state was completely corrupted.
The author literally had to shut the entire session down and restart it the next day to clear the glitch.
What is fascinating here is the stark contrast in capability. You have a system sophisticated enough to architect a complex asynchronous web stack in Rust,
Yeah.
but fragile enough to fall into a bizarre, repetitive loop like a broken record.
It's so jarring.
And beyond those overt technical glitches, there were deeper systemic issues regarding how the AI understood its operating environment.
Right. The author noticed a pattern where Claude would make entirely untested assumptions. For example, it confidently issued cell commands using bash syntax.
Nice.
But the IDE environment was actually running PowerShell.
Oh, so the command would fail.
Right, the command fails, the AI registers the error, realizes its mistake, and only then issues the proper PowerShell command.
It highlighted a severe lack of situational awareness. It simply didn't check where it was before it started executing commands.
Exactly.
And that blind spot regarding its operating environment actually mirrors a much more dangerous blind spot in how it perceived the software's architecture.
Yes, and that lack of deeper context leads us to the most serious failure of the entire experiment. This was a massive security nightmare.
Let's get into it.
In the original Python codebase, the author had very specific security intentions. He used a login validation decorator to protect all the web UI routes.
Right.
Now, a decorator in Python is essentially a little piece of code that wraps around a function and acts like a bouncer. If you don't have an active session, it immediately bounces you back to the login page before the function even runs.
It is a standard, robust way to handle security in Python, ensuring that no one can access the admin panel or execute sensitive actions without explicit permission.
Right. But when Claude migrated the code to Rust, it completely ignored that pattern.
Just dropped it entirely.
It left almost every single route on the admin UI entirely unprotected.
Right.
We are talking about routes that perform destructive actions, like deleting blog posts or altering system settings.
That is wild.
Anyone could have navigated to those URLs and wreaked havoc without needing to log in.
This highlights the most terrifying aspect of the migration. Claude never mentioned it was dropping those security checks.
Nothing. Total silence.
Right. It didn't leave a comment saying, I see you have decorators here, but I am not sure how to implement them in Rust, so I am skipping them.
Yeah.
It was a completely silent failure.
The author only discovered this gaping security hole because he was meticulously inspecting the generated code by hand.
And when the author forced the AI to add the validation back in, did it use a clean approach?
No, it didn't use an elegant modular solution at all. It didn't use a Rust macro, which is essentially code that writes other code to handle repetitive tasks cleanly.
Okay, so what did it do?
Instead, it just copy-pasted chunky boilerplate validation logic into the top of every single route function.
Oh, that's terrible.
It was messy, it bloated the code base, and it completely missed the architectural intention of the original design.
AI coding tools tend to only do as much planning as you explicitly force them to do.
Right.
The author noted that the more persistently you define the rules, boundaries, and security requirements for the model, the more consistent your results will be.
But more consistent doesn't mean flawless.
Exactly. It just means the developer has to take on the burden of setting the guardrails constantly.
Which perfectly transitions us into the author's ultimate lessons for the listener. After days of this push and pull, migrating a huge chunk of functionality to Rust, he synthesized his experience into 3 major takeaways.
Let's break those down.
Starting with takeaway number 1, know the source and know the target.
This principle is fundamental. If you do not know what you do not know, the AI simply cannot save you.
Yeah.
The author had more experience with Python than Rust, but he possessed enough foundational knowledge of Rust to understand that just because code compiles does not mean it is actually doing what you intend.
Right. Automation is an incredible tool for augmenting your existing experience, but it absolutely cannot replace it. You need deep, hard-won expertise to spot subtle, dangerous omissions like that security gap.
It is exactly like using a complex calculator. If you don't understand the basic principles of algebra, you won't realize when you've typed in the wrong formula and received a wildly incorrect answer.
You'll just blindly trust the machine's output.
Exactly. You cannot audit what you do not understand.
Takeaway number 2 from the author, expect to iterate. And this one really digs into the psychological toll of this specific kind of workflow.
The difference in the type of frustration you experience is key here. When you are writing code yourself and making iterative changes, the process is deterministic.
It's you versus the computer.
Right. If something breaks, it is because of a specific logical rule that you can track down, understand, and fix. The computer does exactly what you tell it to do, even if what you told it to do was wrong.
But when you introduce an AI agent into the mix, that dynamic shifts completely. It becomes you versus the agent versus the computer. You introduce indeterminism into your workflow.
Precisely. You are no longer just fighting logic errors. You are fighting the unpredictable nature of a language model. You might ask it to adjust the padding on a button, and it randomly decides to rewrite your entire database schema in the process.
It's mentally exhausting.
Because you are constantly trying to wrangle an unpredictable middleman. You have to anticipate that you won't get what you want on the first, second, or even fourth try.
Writing code is a constructive process. You're building something piece by piece. But auditing AI-generated code is a forensic process.
That's a great way to put it.
You are investigating a crime scene of logic that you did not create. Forensic analysis requires a significantly higher cognitive load, which makes that prompt-generate test loop feel more like a hostage negotiation than actual programming.
Yeah, that's spot on.
Which brings us to the final hard truth from the author. Takeaway number 3, take full responsibility.
As the developer, you are the one saying yes to the code. You are the final authority.
You own it.
You cannot abdicate that responsibility to the AI. You cannot just look at a green check mark from the compiler, see that the basic tests pass, and assume the application is production ready.
It's not just about making the code function. It is about how the code functions within the ecosystem of that specific language.
The generated code must utilize the target language's metaphors and idioms properly. If you use an AI to write Rust code, but the logic is structured exactly like Python.
Like those missing decorators.
Exactly. You are going to create massive technical debt down the road. The application will be brittle and difficult for other Rust developers to maintain.
So what's the ultimate advice here?
The author's advice is clear. If you are not comfortable with the technologies you are using, you need to learn the landscape first, before you ever crack open an AI prompt. The AI is a tool to accelerate your execution, not a substitute for your foundational understanding.
If you are listening to this right now, whether you're gearing up for a massive software migration project or you're just curious about the practical limits of generative AI, keep this experiment in mind.
It's a sobering reality check.
AI can absolutely ride shotgun with you. It can read the map, it can suggest a faster route, it can even change the radio station when you get bored, but it is nowhere near ready to take the steering wheel alone.
That reality shifts the burden of work in a very profound way for anyone in the knowledge sector.
So what does this all mean for the future of our day-to-day workflows?
This raises an important question about a fundamental transformation in what it means to write software.
How so?
If the future of development is shifting away from writing predictable, line-by-line code and moving towards constantly auditing the highly confident yet often unpredictable output of AI agents, does the core skill set of a programmer need to fundamentally change?
That's a massive shift.
Are we moving from an era of creation to an era of interrogation, where your ultimate value is not measured by how fast you can type out a function, but by how sharply you can cross-examine the machine's assumptions.
Wow, that is a lot to chew on for our next project. Thank you so much for joining us on this deep dive. We hope you walk away with a few new aha moments and maybe a healthy dose of skepticism the next time an AI coding assistant tells you everything is running perfectly.